Hey guys, how are you doing? In today's video we are gonna do some extra limit and we are gonna introduce the concept of vertical asymptote. Basically we are gonna see when your function grows and goes up until infinity at some finite point, which in this case is 0. But grab your pen and paper and I'll see you in a minute. Let's try to compute the limit as x goes to 0 of 1 over x squared. In order to compute this kind of limit, we would love to put 0 in the denominator, but in that case, we will get 1 over 0. And we cannot divide by 0. That's illegal. So this is not a good answer. But what we can do, well, we can try to apply the definition of limits and try to evaluate the function 1 over x squared for value of x closer and closer to 0. Well, we can pick x equal to 0.1, then 1 over x squared would be equal to 100. Then we can pick x to be equal to 0.01, and then 1 over x squared will be equal to 1000. Finally, we can pick up x to be equal to 0.001, and 1 over x squared then is gonna be equal to 1 million. So as x gets closer and closer to 0, then 1 over x squared becomes bigger and bigger, okay? And also it doesn't matter if we plug into plus 0.1 or minus 0.1, because when we square all this number, we're gonna get all the same. So I can just write plus minus, plus minus, plus minus. So whenever we see this behavior, meaning that when I'm getting closer and closer to some value for the x's, and then my function gets bigger and bigger, we say that our function is going to plus infinity. So we can conclude that this limit is exactly equal to plus infinity. Okay? Now, whenever we're going to see the situation that we have 1 divided by something who gets closer and closer to 0, then we're going to be sure that the limit is going to be infinity. What we have to actually understand if up in front here we're going to get a plus or a minus. So if we're going up or down, basically. As a second example for today's video, I want to show you the limit as x goes to 1 of x plus 2 divided by x minus 1. As always, what we're going to do, we're going to just plug into the value of x first to see what situation we have to deal with. So when x goes to 1, x plus 2 goes to 3, divided by 1 minus 1 is 0. So already this tells you something about this limit. Since we have a number divided by 0, which means that we have a number divided by something which is getting smaller and smaller and smaller, then this limit is gonna be equal to infinity. But what's important is that what it doesn't tell you if this limit is gonna be plus or minus infinity, okay? So this you have to discover it, and how you discover it, making a more accurate analysis of your limit. Specifically, what do you have to do? Well, in all this situation, you have to remember that a limit is equal to something if the right limit and the left limit are the same. Which means that we have to compute both the limit as x goes to 1 from the right side, which is 1 plus of x plus 2 divided by x minus 1, and the limit as x goes to 1 minus of the same quantity. If these two are the same, then we can conclude also that the initial limit is going to be the same. Otherwise, if these two are different from each other, then the limit will not exist. So let's start from the right side. So as x goes to 1 plus, the numerator goes to 1 plus 2, which is 3 plus, divided by, now x is slightly bigger than 1, because it's going from the right side. So if we draw a little plot, we are getting towards 1 from this side. So we are approaching 1 from this side. Well, we are gonna get to a 0 plus. And now what do we have? We have a positive number divided by another positive number, which is gonna be a positive number, so it's gonna be a plus. And since we have a number divided by something really small, we're gonna get infinity. So this limit is equal to plus infinity. What does this mean? It means that if we draw this line for x equal to 1, then as x approaches 1 from the right hand side, our function will do something like this. So it's going to plus infinity. Now let's go from the left hand side now. So we are approaching 1 from this side. Well, now in the numerator we are gonna have 1 minus plus 2, which is something a bit smaller than 3. So it's gonna be 3 minus, divided by, now x is slightly smaller than 1. So it means that in the denominator we're gonna get a 0 minus, which is a number which is negative and is approaching 0. So well, now in the numerator we have still a positive number. This doesn't change because 3 plus or 3 minus is still gonna be positive. But in the denominator now, 0 minus is something a bit smaller than 0, which means that it's negative. And now a positive number divided by a negative number is a negative number, so minus. And now since we have a number divided by something really small, we're gonna get infinity. So minus infinity. So graphically, what does this mean? It means that as we approach 1, from the left hand side now, the function will do something like this. Okay? And this green vertical line is still gonna be called vertical asymptote, but the function will approach 2 different infinities if you come from the right side or from the left side. Moreover, the fact that these two limits are different tell us that the initial limit do not exist. So this is D and E, because the right and the left limit are different from each other. For the last limit of today's video, we are going to compute the limit as x goes to 1 or 1 over ln of x. And as always, we start by plugging into the value x equal to 1, and we get 1 divided by the log of 1 is 0, so we get 0. Okay, great. So as in the previous case, we can immediately conclude that this limit is going to be equal to infinity, but as before, we have to figure out the sign, if it's going to be plus or minus. So again, we're going to compute the right limit, the left limit, and then we're going to check if the two coincide or not. Now, let's start with the right limit. The limit as x goes to 1 plus of 1 over the log of x. And now it's going to be useful to try to plot the function logarithm. The function logarithm looks something like this. This is going to be x equal to 1, and the function goes something like this. Okay, so it passes from 1, and for x equal to 1 is equal to 0, and then after 1 is positive, and before 1 is negative. Okay, great. So when we compute this, what do we have? We have in the numerator we stay with 1 divided by the log of 1 plus. Now 1 plus means that we are approaching 1 from the right hand side, where the function is still positive, which means that this is going to be a 0 plus. And now we have a number, 1, which is positive, divided by another positive number, so we're going to get a plus. And then, since we have a number divided by 0, we're going to get infinity. So, from the right hand side, this limit goes to plus infinity. Now, let's try to go from the left hand side. So, the limit as x goes to 1 minus of 1 over the log of x. The numerator stays the same, remains 1, divided by, now 1 minus, we are approaching 1 from the left-hand side, where the function is still negative, which means that we are approaching 0 minus. And now we have a positive number divided by a negative number, which means that we get a minus sign. And now since it's 1 divided by 0, we are going to get infinity. So again, as before, this function from the right-hand side goes to plus infinity, from the left-hand side goes to minus infinity. If we want to quickly sketch this, again, we have 1 here. This is going to be our vertical asymptote. And as we approach 1 from the right-hand side, we're going here to plus infinity. And as we are approaching 1 minus, we are going to go to minus infinity. Okay? So these are the two functions. And the line x equal to 1 is going to be our vertical asymptote. Again, as before, the two limits are different, which means that the initial limit do not exist. That's all I have for you for today. See you next time.